Today, we'll be talking about the batteries that are in the site. This topic will cover not only the mobile network sites, but anything that is supplied by a battery. Now, first of all, why are the batteries available in the sites? Now, when the power cuts off from the site, the batteries do the backup process, as it is the backup available to supply the devices that are in this site till the electricity gets back, or till the generator or the generator technicians see what the generator problem is and solve it. So it gives backup time for the devices to work till the electricity problem that supplies the site is resolved. And that's the whole idea of the battery. Now, an important question that you must understand and know: why do we use DC volt in devices of telecom? As AC can be stored in the batteries, but DC can be stored in batteries. So if I will use, let's say, for example, the AC, once the source that provides me shuts off, the network will drop. Or let's say if I use DC. Now, in case of DC, if the source that supplies the site cuts off, you can use the DC batteries. So you can supply the site till you solve the problem. So that is the function of the batteries and why we use DC, not AC. We said that our telecom devices work on negative 48 volt discharge, or volt DC. And this negative here is not a negative value, it is an inverse value. So it can protect the devices from rusting and to decrease the device temperature, and it gives more protection to the devices and the employees working on these devices. The thunderbolts repel with the negative charges. So since I want 48 VDC or volt DC, I need a bunch or number of batteries to be connected continuously with each other so they can give me this 48 volt DC. So if I have a battery of 12 volts, I can create 48 volt DC. I will need 4 batteries. So if I have 12 volt batteries, I will need 4 of them to be connected to each other. And if I have a battery of 2 volts, I will need 24 batteries to be connected to each other. And that's why you see sites with 4 batteries, sites with 24 batteries. And even if there is a battery of 8 volts, so I will need 6 batteries. So bottom line, I need to connect a group of batteries together to give me the number of 48 volt DC, in which I supply the telecom devices with. All right. Now, you'll find here 12 volt batteries connected. This is the 12 volt batteries. Let's raise this so you can see it clearly. So this is the 12 volt batteries, all right? And you can see that they're connected by these connectors together, all right? So 12 times 4, as you can see, is 48. And then they're connected to the rectifier. And all of these together give 48 volt DC. So this is called altogether, this is called one string. So it's called a string of batteries. So this is one string. Now, this is another type, which is 2 volts. Now, if you count them, you'll find them 24 batteries. So 1, 2, 3, 4, 5, 6, 7, 8, and then 8 times 3 of these, so 8, 8, 8. That's 24 batteries in total. They're all connected to give me 48 volt DC, and this is used in the telecom devices. And all of this together is just one string. Something important you must know about the batteries is what is called ampere per hour. Now, the ampere per hour or ampere hour is the value of ampere that one string of battery can supply for 1 hour or for an hour. So if we said that the ampere hour of this, the ampere hour of this battery type is 155 ampere per hour, which means these batteries can supply a load with a value of 155 per hour, 155 for 1 hour. This should be what happens, but actually what happens is that it gives me 155 amperes for 45 minutes or 40 minutes, depending on the battery efficiency, all right? Now, last time I told you guys that we'll talk about something that we mentioned later on. We said that the 12 volt batteries, I connect 4 of them, so they give me the number of 48, correct? 48 volt DC. And if 2 volts, I connect 24, so it can give me the number 48. So let's put that here. So if, again, let me just stop down here. So again, if I said 12 volts, then I will need, sorry for that. Now 12 volts, then I will need here 12 volt batteries. I need 4 of them to give me the 48 volt DC. And 2 volt batteries, I need 24 to give me the 48 volt DC. Sorry for this part. Okay. 48 volt DC. Now, if all of your talk is about 48 volt DC, then why is the volt that appears on the rectifier is like 53.5 volts or 54 or 54.5? How did this come? And I'm supposed to be actually 48. I'll tell you simply, the battery of 12 volts in case of full charging isn't actually 12 volts. 12 volts can actually be, let's say, for example, 13.10 or 13.3, for example. All right. So it can be 13.3 or 13.10. And in this case of this is the case of full charging. And the same goes for the 2 volts. It can be 2.41 in case of full charge. So if you multiply this 13.3 or 13.10 times 4 batteries, it will give you the value, which is close to 53.5 volts. And if you multiply this 2.41, for example, multiplied by 24 batteries, it will give you the value of 53.5, 52, or 52.5, all right? This is the story of why I have 48 on the rectifier, and it appears 53.5 or 54 or 54.5. As in case of the battery, full charging, it's higher than 12, all right? Okay. Sorry for that. Now, let's talk about the types. There are a lot of battery types. these in the pictures are just like two types. What makes a type different from another type is its ampere per hour. So for example, the batteries here are 155 ampere hour, but these batteries like are 450 or 400 ampere per hour. So there's a difference in withstanding and the time that it will work. Another thing that makes a difference is the capability of the battery to withstand temperature. So if the batteries withstand more temperature, then it's more expensive and better, of course. As the ampere hour gives more efficiency to the batteries, then the batteries withstanding temperature also gives it good efficiency. Now let's talk on how the batteries are connected to each other and connected to the rectifier. Now the batteries are connected to each other, as we mentioned, by these connectors, all right? That comes from the positive, let's say, of this battery. So this is the positive of the battery to the negative of the battery. And here is the positive, and here is the negative, positive, and negative. All right. Till we have one positive side and one negative side that is unattended or empty. Now, this is, as we mentioned here, let me show you guys something. We said that this is the circuit breaker. If we remember that this is the circuit breaker part. All right. So let's say that this negative part goes here and the positive part goes here there. All right. So the circuit breaker, as we mentioned earlier in the rectifier, which is from the components of the rectifier. And we said that there is a copper bar, as we said, in the rectifier, and it has to be written positive on it. But it's not actually positive part of the rectifier, as we explained that it is the part that combines on it, the positive parts, as it is negatively charged. The circuit breaker is the part where it combines the negative parts, as it is the positive part of the rectifier. All right. Now, I will connect the, as we mentioned here, so the, I connect the string, which has to be negative 48 volt DC and has to be reverse effort. So I need to connect negative on positive and positive on negative. So I will take from the negative of the battery and connect it on the positive of the rectifier, which is the circuit breaker, and take the positive of the battery and connect it on the negative charge, which has the positive side. But why positive? Because it's combined on it, the positive parts, but it is negatively charged. So here I did a reverse connection. All right. So again, the positive, as we mentioned, all right, goes to negative and negative goes on positive. And here I connected the negative 48 volt DC. Now, just for your information, I used these two strings simultaneously or together when the power cuts off. So I use them simultaneously or together when the power cuts off, as they charge and discharge at the same time. So that's why the strings are connected to the rectifier in parallel, not in series. So I can use them both at the same time. Now, why do I go to sites and find a site, let's say, having one string, and a site having, like, let's say, two strings, another site having like 10 strings? This depends on two things. The first and most important is the load of the site. The second thing is the importance of the site itself. So does this site serve a crowded place? And it can be a small site, but serves a ministry or an important governmental sector. But I can't wait for any problems to happen in this site. So they will increase the number of batteries in it. So if any problems that happen in it, or the electricity or generator that supplies this site, the site still functions for a long period of time. So these are the two things that I depend on to increase or decrease the strings. So depending on the site importance and the load available on the site. Now, the batteries live longer depending on two factors: the weather environment surrounding the batteries, and the second thing is the charging and discharging rates. Let's first talk about the weather environment. The heat damages the battery. So if the ventilation of the site or shelter of the site is inappropriate, it will damage your battery. The second thing is dust. The batteries have like pores for ventilation in a way. The dust enters these pores and destroys the ventilation process of the batteries. So that's why regular maintenance is done to clean from dust. And it's better off dry dusting first by a blower or let's say a piece of cloth or a dry cloth. As if you, for example, used water first, this dust will turn into mud. Sorry for that. So again, this dust will turn into mud and will close the battery pores, all right? So again, if it's better off by dry dusting by a blower or piece of cloth, as we mentioned, instead of using water first, as this dust will turn into mud and will close the battery pores. Now, the second thing is the charge and discharge rates. If the batteries are continuously charged without electricity being turned off for, let's say, a year or two, then unfortunately, these batteries get damaged. And if the batteries aren't charged for a long period of time, the batteries also get damaged. And we can see this in our laptops and mobiles. Let's say if we leave the batteries charging in a mobile for 2 days, or the mobile charging for 2 days, then it will affect its battery efficiency. The same goes for the laptop. And the same if you do not charge your mobile or laptop for a month, the batteries still get damaged. So the continuous process of charging and discharging has to occur. Now, recently we have the BDT, or which is called the battery discharge. The battery discharge. Okay, so again, I'm sorry. All right, I apologize for that. Now, we have the BDT, which is the battery discharge test, which is a test done for batteries to reassure the battery efficiency in the site. And this is the most common use for all people, all right? That's what we're used to. Now, there's another use for this BDT, or battery discharge test, which is that I preserve the charging and discharging rates of the batteries. So if I have a site that's been a year or two and the power didn't cut off in it, when I go to the battery discharge test, I do discharging. So in this case, I preserve the battery. Now, this battery discharge test is done by forcing the battery to discharge, by cutting off the electrical current source that is coming to the site. So I cut off the breaker cable that supplies the electricity to the rectifier. So the backup batteries start to work. And after the backup batteries work, I start measuring the volts of the batteries compared to time. So, for example, after half an hour, I see what are the battery measurements. And let's say after 60 minutes, I see what are the battery measurements as well. And after 120 minutes is the same. I see what are the battery measurements as well. So intervals of half an hour each. And I start to, I start to do the batteries discharge properly. I start to see if the batteries discharge properly and logically, or is a battery that is not discharging well, all right? Now, here you come with something called an avometer, all right? You get it on the DC vault and then put one part on the positive and the other part on the negative. And start to see the number on the screen of the avometer and start recording your measurements. This is all the story of the batteries and its numbers and what it's used in. Now, by here, we finished the AC and DC power. And the next video, we'll be talking about the radio scope. Thank you so much.